Copper is and always has been my favorite element. Not only are copper compounds useful, they have uses in almost every aspect of science. Copper can usually exist in two oxidation states, +1 and +2. If you're making any sort of electrical device, copper-1 compounds tend to be better. There are many ways to make copper oxide. You could make it directly by reacting oxygen with copper, but this doesn't give you very good control over the shape or properties of the oxide, and you'll often overdo it, and the red copper-1 will be destroyed to leave only black copper-2. While I was looking for a way to synthesize copper-1 oxide, I found a simple experiment most people do in high school. Benedict's test for reducing sugars is a simple chemical test that will show you if a reducing sugar is present in a particular solution. Benedict's reagent is the mixture used for this test, and it's a mixture of copper sulfate, sodium carbonate, and sodium citrate. And if you add a reducing sugar and heat, the solution will go from blue to yellow and then eventually to red, due to the formation of copper-1 oxide and copper metal. Now, this would be simple enough to do to make copper oxide, but I didn't have any sodium citrate, and I didn't like the amount of steps to get this right and wanted to use what I had on hand. So I ran a series of experiments to find good alternatives that followed a similar mechanism. For my procedure, we only need 3 compounds: copper sulfate, ascorbic acid, and some sodium hydroxide solution. To begin, we get some copper sulfate, I used about 2 grams in this case, and dissolve it in deionized water. I'm using 100 milliliters. Then we add some 30% sodium hydroxide solution to form copper hydroxide. In this run I used a milliliter, but that wasn't enough, as you'll see later. Slowly add the hydroxide and mix the solution so that it's a homogeneous opaque blue, and I'm using a lab stirrer for this. Then we add in small amounts of ascorbic acid at a time. Ascorbic acid is just vitamin C, here I'm using it in its pure form. The idea is to reduce the hydroxide down to copper oxide. If you add too much ascorbic acid, the copper oxide will be reduced further down to particles of elemental copper. So only add small amounts at a time and wait about 20 minutes between additions. You're aiming for a canary yellow solution. In this case, because I didn't add enough hydroxide, there's some unreacted copper sulfate left in the solution, making the yellow look sort of brown. This threw me off, so I ended up using too much ascorbic acid. If you were to look up pictures of copper-1 oxide, you'd be greeted with dozens of pictures of bright red powders. Now, this is probably confusing because I just said to aim for a canary yellow solution. One of the quirks of copper-1 oxide is that if the particle size is sufficiently small, it actually looks bright yellow or orange instead of red, much the same way that quantum dots look different based on their size. Sometimes during the synthesis you may get a mixture that turns orange. There are 2 reasons for this. If you add too much ascorbic acid, metallic copper begins to form, and the combination of yellow copper oxide and pink copper gives an orange mixture. Eventually, if you continue the addition, you'll get a salmon pink solution of only copper particles. The other reason is, as I mentioned before, is due to size. During the washing steps I'll cover in a moment, the particles tend to agglomerate a bit, and the increased size shifts the color closer to red. The reason I say to aim for a canary yellow solution is because then you've got the best chance of not having any copper contamination in your mix. When you've got your solution the right color, let it settle and decant off as much of the liquid as possible. Then add some deionized water to wash and then allow it to settle again. Repeat this 2 or 3 times and then finish with a wash of acetone. If you don't wash sufficiently, then when you go to dry the material, you'll end up with a green mush mixed in with your oxide, which isn't ideal. The nice thing is that if there is any copper contamination in your particles, when you dry it out, the copper particles will oxidize to copper oxide, so you'll just end up with a more brown-orange powder. So what's the point of making this copper oxide? Well, as you can see, it's quite colorful, and it's been used as a pigment and as an anti-fouling additive to paints that'll be used in aquatic environments. It's also a fungicide. In terms of electrical applications, the first diodes were based on copper oxide, as it's a very good p-type semiconductor. I'll be using it in everything from electrochemical devices to solar cells. Okay guys, that's all I've got for this video. I hope you've enjoyed. If you have, be sure to subscribe, rate, and comment. If you haven't already, be sure to check out the Facebook page, Instagram, and social media stuff where I post behind the scenes, extra content, daily content, and all that kind of stuff. If you're interested, my research can be found at my website, all links in the description. And this isn't actually the first copper video that I've done. You can see one of them in the top left where I show how to make these incredible sparkly copper nanoparticles. And if you missed it, you can see last week's video where I take you through the process of making cold process soap, which you can get to in the top right. And I'll see you next time.